Hi guys, welcome to Science in 5. In this video we're going to discuss proportion theorem. Suppose I have a line, not very straight, but it's a line. It's straight in my mind, so it's straight. AB. We're going to divide the line AB by adding a point C. Now this point C that we've added is going to divide this line AB such that 4 parts of this line is AC. Nice C, please. 4 parts of the line is AC and only 3 parts of the line is CB. So 4 parts of this line AC, 3 parts of this line CB. We have divided this line AB into an interesting ratio, or in proportion. Because what's happening now here is that if I take the ratio of AC over CB, what am I going to get? If I say AC divided by CB, I will divide 4x over 3x. The x's can cancel. This simplifies to 4 over 3. So side AC and side CB have been divided into proportion. It doesn't always mean that AC is going to be 4 units or CB is going to be 3 units. Because when I look at this ratio, that's what it seems to suggest to me, that AC equals 4 and CB equals 3. In other words, if I write this ratio as AC over CB is equal to 4 over 3. It's not a given that it's going to be 4 units and 3 units. Unless x equals 1, then we can say AC is 4 and CB equals 3. Or unless we are told that this line AB is actually 7 units. Then if it's 7 units, then it makes sense to say that AC is 4 units, CB is 3 units. Or if we are told that the line AB is 4 meters, AB is 7 meters, AB is 7 meters, then AC can be 4 meters and CB can be 3 meters. Right? Now let's make this whole thing interesting. Let's suppose we draw in another line. Let's call this line AD. We are drawing in this line AD in such a way that if we add a point here, E, it's going to divide again AD into the same ratio. In other words, AE becomes 4 parts of the entire length of the line. ED becomes 3 parts of the entire length of the line. So what's happening now is that I am going to get AE over ED equal to 4y over 3y. This again simplifies to 4 over 3. So, interestingly, these two sides have been divided into the same ratio. Okay, so E and C are points that are dividing two lines that have got the same starting point, a common point that are drawn from the same point into the same proportion. So if I was to join these lines E and C, right? And then I also join the lines D and B. What would I observe is that EC and DB are actually parallel to each other. Very interesting observation. You can try to make this construction, make a line, divide into the same proportion, make another line, divide into the same proportion. Remember, AD and AB do not necessarily have to be the same for this idea. They're just being divided in the same proportion. For example, AD could be 21 units and AB could be 7 units. They're still divided into the same proportion. Okay. Now, you'll discover that if you join these 2 points that have divided the 2 sides using the same ratio, this line that you draw EC becomes parallel to DB. Interesting. So now, when we've got a line that is drawn parallel to the two sides of the triangle, we now know that this line EC divides the two sides into proportion. We can now write AE over ED is now equal to AC over CB. And that is the basis of the proportion theorem. Remember, it does not mean that AE is equal to AC all the time. There are times when Y and X are the same. Yes, this can be an isosceles triangle, or it might as well be an equilateral triangle as well, AEC, that's fine. ED is not always necessarily equal to CB unless E and C are the midpoints. If E and C are the midpoints, then it's fine. These two become equal. So the interesting thing is now to be able to use this ratio. That's why it is always good to write them like that. 4 parts, 3 parts. The total length is 7 parts. 4 parts, 3 parts, total length is 7 parts. By means of introduction, that is how the proportion theorem is all about. Okay, so now we're going to need to perform calculations based on this proportion theorem as well. Now, before I run away from this brief introduction, I also need to highlight the fact that if you look at this diagram, I've drawn two triangles. I've drawn two triangles, triangle A, E, C, and I've also drawn triangle A, D, B. What can you tell me about these two triangles? Are they congruent or similar? I don't see them being congruent because AE is definitely smaller than AD. So they cannot be congruent, okay? But they are similar. How would you prove that these triangles are similar? Well, if you look carefully, you'll discover that these triangles are actually equiangular. In other words, they've got the same angles. If two triangles are equiangular, it means what? They're similar. And if the two triangles are similar, we can also write their sides in proportion. So we've got already the proportion theorem, but we've also got these other sides in proportion. Side AE and side AD. Side EC and side DB. Side AC and side AB. So, you've got to always remember that in as much as you're going to be dealing with the proportion theorem, do not leave out this idea that these two triangles are similar. And because these two triangles are similar, it means we've also got AE over AD being equal to EC over DB. So with these two proportion expressions, you should be able to solve problems involving triangles. So these are the two expressions that you're going to need, okay? So based on the information that you get, you've got to sift out and say, can I use the sides of the similar triangles? Or can I just use the proportion of the sides because EC is parallel to DB? Okay, thanks for watching, guys. In the next video, let's tackle some problems. Now, let's make proportion theorem simple. Let's make it as easy as possible. Let's demystify it. Okay, sharp.